Hey, hi guys, welcome to my channel. So today we'll be studying about a form of data structures which are somewhat different from the previous simple data structures which we have learned, which are tuples, dictionaries, and lists. So from here onwards, we have to call special libraries and functions to create advanced data structures. Today we'll start with NumPy. Okay, so NumPy has various, attributes, say array formation. If you want to create arrays, matrices, right? If you want to generate random numbers, all these functionalities are present inside NumPy. When we want to call these functions from NumPy, you have to import the NumPy library first. You cannot simply directly call array like this. It will not understand. The machine will not understand. So you have to first import NumPy as NP. I can directly import NumPy also, but if I simply import NumPy, I have to call these functions as NumPy.array, NumPy.matrix, NumPy.whatever random int. So whenever we want to call a function from a library, I have to initiate the library first, then call the function using a dot from the library. So library.function is the syntax. Instead of writing the 5-letter word again and again, I'm abbreviating it as NP. So machine will know that NumPy is actually NP. So I can simply do NP.array. How it is constructed, right? Typically, we have to put it inside a list. So basically, a list can be converted to a NumPy array. So if I have a list, say, and if I do NP.array of A, I'll get this particular array. And if I want to convert it back to a list, what I'll do? B is equal to this. I'll simply do list of A. So they can be converted from one to the other. Now, there is one more special feature of NumPy, which makes it very different from tuples or lists. As I mentioned in the first class of lists, that list does not understand dimension. It does not understand what is rows and columns. So here, if you look at NumPy arrays, let's say B is the array, because if you type of B, it basically gives you a NumPy array, and my B. If I do B dot shape, number of rows, comma number of columns, dimension. So there are no possible of columns here because it's just one vector, and that's why it is showing as 5, nothing. And if I do B dot size, 5 elements inside that array. Even if I do length of B, there are 5 elements inside that particular array. Now, remember we studied nested lists, a list within a list. D is equal to, say, there are 2 lists inside the list, 1, 2, 3, and let's say 4, 5, and 6. And we have D as this. Now, if I convert it to an array, what happens? Didn't it form like a matrix-like structure? We have the first row as 1, 2, 3, and the second row as 4, 5, 6. If I want to slice it, we have to slice it just like the way we did it in lists. So if I want to find out 2 in lists, I would have done it like this: D of 0 of 1, because my 2 is present in the first element 0, and inside the first element it's the second element, so it is 1. Let me save this array as E. In arrays, I'll use a 2-dimensional slicing. So I'll use E of, what is the row? Row number is 0 because the first row 1, 2, 3, and then 4, 5, 6 has come. So you have 1, 2, 3, and 4, 5, 6 in 2 different rows, right? So this is in the first row. So 0, comma, the column is the second row. First row and second column will give you this 2 value. So this is exactly what we're going to do now. We'll put here as 0, comma. So instead of this, I use a 2-dimensional slicing where you separate it by a comma. The first index represents the row index. The second index, which is present here, represents the column index. अब इसका shape क्या होगा? E dot shape, if I do, it will be a 2 cross 3 matrix, 2 cross 3 array, rather, I would say. Matrices are typically 2-dimensional in nature. Matrix cannot be 3-dimensional. But arrays can be 1-dimensional, 2-dimensional, can be multi-dimensional also. So now if I do E dot size, what is the size? Number of elements inside that particular array. Number of elements in a matrix or 2D structure is always number of rows multiplied by number of columns, which is 2 into 3. And of course, there are 6 elements here. Now, when I do length of D, say length of D, it'll give me 2. Why? Because there are two elements inside it, nested list. Similarly, if I do length of E, it will again give me 2 because E is nothing but an array of nested list. But if I do E dot size, it will give me 6 because there are 6 elements present inside this entire array. E dot size basically gives you the rows multiplied number of columns concept. Arrays understand dimensions. That's why you could slice it out using row and column indexes separately using a comma. So guys, this is the introduction to NumPy module. We'll try to explore more and more in the upcoming videos. Stay tuned. Please like, share, and subscribe. Hope you like today's video. See ya.